All right, we just passed the halfway point if you're following along sequentially. Number 26, there's about 50 problems in this list of integrals that I found from Princeton University. Okay, number 26, integral of x minus 2 times square root of 9 minus x squared dx. How do we approach this? This is a weird looking integrand. I personally never seen something like this before, but no need to be intimidated by this. It's actually not bad at all. Okay, we can first distribute the square root term to both the x and the 2, okay? And then split up the integral. The first integral, that's why I said it's not intimidating. We know how to solve this. This can be solved by a substitution. U is 9 minus x squared. Du is minus 2x dx. So then it becomes minus half integral of square root u du. And then we just use the power rule from here. I'm going quickly. You can definitely pause the video if you need to, but hopefully this is straightforward by now, the substitution. Okay, and then we back substitute. Okay, now let's worry about the second integral. This one is not bad either because something squared minus something squared, we can do a trig sub. Okay, set up the triangle as per usual. Again, if you're not familiar with this, please go check out my crash course in trig sub video where I explain why you should set up this triangle and how to set it up, okay? So we need everything in this integrand in terms of y. So we need x to get dx. So x is 3 sine y from the triangle, or sine y is x over 3. So x is 3 sine y. Dx is 3 cosine y dy. And then the square root term we can get by cosine. So it's 3 cosine y. Okay. So we substitute. We would get 9 cosine squared y dy. This is familiar territory now. We just use the half angle identity to solve this, okay? So that's what happened over here. And then we integrate. So that's minus 9y, minus because of this minus 9 over here, minus 9 over 2 sine of 2y plus c, okay? Now what is y? Y, oh, by the way, here I use the trig identity that sine of 2y is 2 sine y cosine y. So that's what I did first, okay? Now what is y? Let's go back to our substitution here. You can use any of the arc trig functions, inverse trig functions, but might as well use these arc sine because we have a definition here. So y is arc sine of x over 3. And then we also need to square root. Sorry, let's just do that first. Yeah, it's the arc sine of x over 3. And then we need sine y and cosine y. So then sine y is just x over 3, cosine y is just square root term over 3. That's what happened right here. And then just some further simplification because you can cancel this 9 and these 2 3s. So that's what I did, and that's my final answer. Okay, so this integral was not bad at all, as you can see. We just had to do a simple distribution. Okay, and then again, the first integral was just a simple substitution. And the second integral was just a typical trig sub. All right, hopefully this was helpful. Please like and subscribe as always if you found this helpful. And hopefully see you in the next video as well.